In this video, we're going to apply the first derivative test and find the relative extrema of f of x equals x squared minus 4 to the 2/3 power. We first need to note that f is continuous along the entire real number line, and we'll find the first derivative, f prime of x, which is equal to 2/3 times x squared minus 4 to the negative 1/3 times 2x, applying the power rule and chain rule here. This simplifies to 4x over 3 times x squared minus 4 to the power of 1/3, where 4x was obtained by multiplying 2 times 2x, and we moved our statement x squared minus 4 to the negative 1/3 down into the denominator along with 3. X squared minus 4 can be factored to x minus 2 times x plus 2 and by setting each factor equal to 0 and solving for x, we see that the derivative of f will not exist when x equals 2 or x equals negative 2. Furthermore, solving for x would leave us Actually, let me go to the next screen. It would leave us with x equals 0. Since setting this equation equal to 0, multiplying the denominator on both sides would cancel. We'd be left with 4x equals 0. Divide by 4 on both sides, and x equals 0. Therefore, our critical numbers, or critical values, are negative 2, 0, and 2. We can use this information to determine where f may have relative minima or maxima. We'll plot our critical values, negative 2, 0, and 2. With critical values, negative 2, 0, and 2, we'll choose some test points, negative 3, negative 1, 1, and 3. This will help us to determine whether the graph is decreasing or increasing, and identify any relative maxima or minima. Now, if we plug in our test values to f prime of x, then we know that the graph is decreasing at that point. If we plug in test values to f prime of x and get a positive value, then we know that the graph is increasing. So f prime of x equals 4x over 3 times x squared minus 4 to the 1/3 f prime of negative 3. We'll plug in negative 3 for all x in f prime of x, and this will give us a negative result. So we know that the graph is decreasing at f prime of negative 3. Using the test point, f prime of negative 1 yields a positive result. So here the graph is increasing along the interval from negative 2 to 0. Evaluating at f prime of 0 yields a negative result. So again, the graph is decreasing. And finally, f prime of, that's f prime of 1, not f prime of 0. So we plug in 1 for all x and get a negative result. So it's decreasing. And then using our test point, positive 3, f prime of 3 will give us a positive result. So our graph would increase again. This means that the graph of f has a relative minimum at the point negative 2, 0. We know this to be true by plugging in negative 2 into our original function, f. So f of negative 2 equals negative 2 squared minus 4 to the 2/3 power. This equals 0 to the 2/3 power, which is 0. Similarly, we would find that the graph of f has a relative maximum at 0 and the cube root of 16. And we would find this by plugging 0 into our original function f to yield our output, cube root of 16. We would also find one additional relative minimum at 2, 0. Again, plugging 2 into our function f, and our output will be 0. This concludes our example, and we'll see you next time.